Hello, my name is Gulnoza Khakimova and I'm presenting lab assignment number 2. For this assignment we had to create membership inference attacks, and it consists of two parts. The first part is we had to create same target and shadow model, but we have to use different data sets to perform attack. So here I am importing needed libraries, defining hyperparameters. So I'm going to train our model on 7 epochs, and I'm dividing our batch size to 48. A learning rate is 0.01, and here I'm loading our first data set, Cybersecurity, which consists of different images of size 32 by 32. Here, as we can see, examples of it. Our second data set will be LFW, labeled faces in the wild. So here I'm importing them and dividing them to the train datasets and test datasets. Here's an example of it. Also, I'm defining several helper functions which will help us. For example, the first function helps us to download our data. Those are different neural networks. That's a function to train our model. This is a function to calculate weights. This is another neural network. This is a function which will calculate size of our neural network. And also this is tiny CNN, this additional network as well. Those are functions which will evaluate our target model, evaluate our attacker model, etc. So those are all helper functions, and here we are performing our actual attack. As I mentioned before, we are using same model both for target and shadow network. Here we are defining them, applying weights, defining loss, optimizer, and here we are training our model on our 7 epochs, as we can see. So on the last epoch we got our training accuracy is 78% and our test accuracy is 36%. So here we are training our attacker model. Let's scroll down and see what we got here. So as we can see, the loss and accuracy is changing. So our loss is 0.69 and accuracy is 57%. And here we are training our target model. Let's see what we got here. So for training we got 46% accuracy, and for test we got 31% accuracy. I could have, in order to get more accurate result, I could try different models, different neural networks, and increase size of our epoch and adjust learning rate as well. Here we are evaluating our attack. As we can see, train accuracy is 46% and test accuracy is 31%. And here we are just plotting it. As we can see, our graph, it has accuracy, precision, and recall. So accuracy is 51%, precision is 0.53, and recall is 0.38. So part 2, we will use same data sets, but we will use different models for our target network and for our shadow network. Here I'm defining our hyperparameters again, and I'm using Cybersecurity dataset, which consists of different images of size 32 by 32, and it's divided into 10 classes. Here's an example of it. Here I am defining our target model, and we will be using following neural network, and for our shadow model we will be using tiny CNN, which we defined above in our helper functions. Here I am dividing our data, loading our data, so dividing our data into train training datasets and test datasets, defining our loss function, optimizer both for target and shadow, and also we're defining our attack model, and also defining attack loss and optimizer as well. So here we will be training our target model, and let's see what results we got here. So again, I used 7 epochs. So as we can see, on training we got 61% accuracy, and on test we got 53% of accuracy. Here we're training our shadow model, so let's see results on it on 7 epochs as well. So our training accuracy is almost 62%, and our test accuracy is 55%. And here I am training our attack model. As we can see, our accuracy is changing, loss is almost the same. We can see the small change here, and here at the end we see that our loss equals 0.69 and accuracy is 50%. And here we are evaluating our attack model, and as we can see, there is a we calculated precision and recall as well. So and our threshold is 0.99, accuracy is 50%, precision is 0, and recall is 0 as well. So performance on training set is 61%, and performance on test set is 53%. So that's all for today. Thank you very much.